All right, Algebra 2. We just finished factoring, the different types of factoring that, depending on how many terms there were. So in Unit 2, we looked at difference of squares, obviously greatest common factors, and then the trinomials using the X method. And then we went into polynomials with two terms. Again, we look for GCFs, but now we look at sum and difference of cubes, and then three terms again using the X method, and then four terms using grouping. So at the top here, and this chart I think is going to be in probably the Google stream, so if you want to download it, or it'll be on my webpage for you to download. But it just gives you an example of, depending on how many terms there are, what are your first steps? What are you looking for? So you can see in all the steps and all the number of terms, doesn't matter how many terms there are, the first step always is look for a GCF. Once you have that GCF, you have to look at, okay, now what do I have left over? Okay, are there two terms, three terms, or four terms left over? And then you look for the next step. Okay, and then the next step is, okay, well, if I have two terms, I'm looking for a difference of squares, or a sum or difference of cubes, and depending on which one I have, then I continue to factor further. If I have three terms after I pull the GCF out, I want to use the X method. Okay, and I gave examples of using the X method, again, with a trinomial. And then four terms, use your grouping method. Okay, so there's an example of each kind, and the degrees can be higher than what's just shown in those examples, as you've seen in the first lesson of Unit 3. All right, so now we're going to get into solving. All right, so just like in Unit 2 with the quadratics, once we factor, we want to go ahead and try to solve it. And we could use square roots, we could use quadratic formula, just like in Unit 2, that stuff can come back into play now. All right, so we talked about the degree of a polynomial, and that's going to always equal the total number of solutions that a polynomial has. So in this example, 9x to the third plus 45x squared minus 4x minus 20, the degree of the polynomial is 3, so there's 3 solutions. Those 3 solutions can be real, they could all be real, or you could have some real and some imaginary. All right, so anytime you see the term x-intercepts or zeros or roots, term roots, they all mean the same thing. They're the solutions to the problem. You set the equation equal to 0 and you solve it. All right, so when we solve polynomials, the first step is obviously get it in standard form, so it's set equal to 0, and then you're going to try to factor it first. Okay, so once we first factor it in all the different kinds of factoring I've listed there, GCFs, difference of squares, that's DOS, SOP, that's your cubes, sum and difference of cubes, X method, that's your trinomials, the 3 terms, and then the grouping 4 terms. Once you've used one of those for factoring, then you could use square roots to finish solving it, or even quadratic formula. All right, so let's go ahead and do number 1. So number 1, it's in standard form. The degree is 3, okay, because it's degree x to the third. And so that means there's going to be a total of 3 solutions. So I'm just going to put that down just so I know. Once I find all the solutions, I can count them and make sure I got 3. So on this one, I'm going to look for a GCF. That's the first step. Well, they both have x's, so I know I'm going to be pulling an x out. And I know 4 goes into 4/12, so my GCF is going to be 4x. All right, so now I'm going to factor 4x out. So again, factoring out means to divide by that 4x and simplify. So this is going to be x squared and minus, and then this is going to be 3. All right, so we factored it. Now x squared minus 3, we have the difference, and x is squared. That's a square, but 3 is not a perfect square. So this is not going to factor into a difference of squares. Okay, but we can still solve it. All right, so remember, we're looking for 3 solutions. So the 4x on the outside, since there's an x to the first here, that's going to get us one of the solutions. All right, so I set that equal to 0, I'm going to solve it. And then the x squared minus 3, since that has an exponent 2, that's going to get us our other 2 solutions. And that gives us our 3 total that we're looking for. Alright, so let's finish solving this. So here I'm going to divide by 4. So x equals 0 is one of the 3. And then I'm going to add 3 over. So here I can use the square root method to finish solving. Okay, it's going to be square root. And remember, you have to put plus or minus when you square root. And then square root of 3 doesn't simplify, so there's my other 2 solutions, plus and minus. Alright, number 2. This has degree 3, so this is 3 solutions also. So this has 4 terms. So 4 terms, remember, we're going to use grouping. Alright, so I'm going to group the first 2 and last 2. Pull out a GCF. So this is 4x squared. I'm left with x plus 2. Now I have to pull something out of the last 2, and the GCF is going to be 1. So I'm going to pull the 1 out. And so I'm left with x plus 2. Now, because these are the same, we're not going to leave our factoring like that because that's not good. Okay, remember we have to write our 2 sets of parentheses. What's on the outside of both go in one set, 4x squared plus 1. And then x plus 2 goes in the other set. Alright, so remember, the outside parts go in one, and then what's duplicated goes in the other. Alright, so we factored it, now we're going to go ahead and solve it. So the 4x squared plus 1, that's a degree 2, so that's going to get us 2 solutions that we're looking for. And the x plus 2, that's a degree 1, so that's going to get us 1 solution that we're looking for. Alright, so here I'm going to subtract the 1 over. I'm going to divide by 4. I'm going to square root. Now remember, when you square root, I put plus or minus. I'm going to pull that negative out, I, and then I have the square root of 1/4, which will simplify down to 1/2. Okay, square root of 1 is 1, square root of 4 is 2. So that's plus or minus 1/2 I. Right? And then the other one we can subtract the 2 over. So x equals negative 2. Alright, number 3, it's degree 3. And we have 4 terms again, so looking for grouping. So here we have 9x squared can come out. And let's see, we're left with x plus 5. Here we're going to factor a negative 4 out. And we're left with x plus 5 again. Alright, so again we do our 2 sets of parentheses. What's on the outside goes in one set, and what's duplicated goes in another set. Now 9x squared minus 4, you could use square root method on this, but it does factor because it is a difference of squares. So I'm going to go ahead and just factor it. So remember, when you use factoring, a difference of squares, you square root both terms, right? And that goes in both sets, and one's plus, one's minus. And then the x plus 5 will just come straight down. Alright, so now we're going to go ahead and solve this. So here, I have 3x plus 2. Since it's degree 1, it's going to get us 1 solution. 3x minus 2, same thing, it's going to give us 1 solution. And x plus 5, it's going to give us 1 solution. Alright, so when we solve this, we can subtract the 2 over. And we can divide by 3. So negative 2/3. And we're going to add 2 over. And divide by 3. And positive 2/3. And subtract 5. And negative 5 is our other solution, the third solution we're looking for. Alright, number 4, there's no GCF, it's a degree 4 this time. Degree 4, so we're looking for 4 solutions. It's a trinomial, 3 terms, so we use the x. Negative 36 goes on top, negative 5 goes on the bottom. So 2 numbers that we're looking for, it's like negative 9 and positive 4. And we don't divide by anything because we're leading off with a 1. Alright, so we do our 2 binomials. And so remember, because it's an x to the 4th, we have to basically square root it or cut that 4 in half for our exponents. Okay, so instead of x and x, it's x squared and x squared. So it's x squared minus 9, x squared plus 4. Now, from here you could use the square root method, but I will factor this because I know x squared minus 9 is x plus 3x minus 3. All right, x squared plus 4 doesn't factor because it's plus, not a minus. All right, so now I'm going to go ahead and solve it. Remember, we're looking for 4 solutions. All right, so each one of these can be set equal to 0, and I can solve for each one. All right, so here I'm going to subtract the 3 over. So x equals negative 3. Here I'm going to add 3. X equals positive 3. And here I'm going to subtract the 4. I'm going to square root both sides. Get x equals plus or minus. I'm going to pull the negative out, so I get an I root 4. But then root 4 is 2. So I get 2i plus or minus 2i. All right, let's keep going. All right, number 5. It's a degree 4, so there's 4 solutions. It's a trinomial, 3 terms. There's no GCF. I'm going to use the x. Here I have to multiply 2 and 6 together. That's 12 on top, and negative 7's on the bottom. So that's going to get us a negative 4 and a negative 3. But because we're leading off with a 2, we're going to divide both by 2. Right, and then we can simplify negative 4 over 2 to negative 2. So our binomial factors, remember that x to the 4th has to be cut in half. So that's going to be x squared minus 2, and then 2x squared minus 3. Right, so now we can set those equal to 0. And we're just going to use the square root method for solving. Alright, so I'm going to add 2. X squared equals 2. I'm going to square root both sides, so x equals plus or minus root 2. So there's 2 solutions. Then here I'm going to add 3. And divide by 2. Okay, remember, you gotta get that x squared by itself before you square root both sides. So x equals plus or minus. Now I have that radical 3 halves. The whole fraction's under the radical, and I don't want to leave the fraction under the radical, so I'm going to split it up into root 3 over root 2. And then I'm going to get rid of the radical off the bottom by multiplying top and bottom by root 2. Right, so I get plus or minus root 6, because root 3 times root 2 on top is root 6. And then on the bottom, root 2 times root 2 is root 4. And radical 4 is the same as just 2. So there's my other 2 solutions. So remember, you're looking for 4. All right, and the last one, number 6. Let's see, there's no GCF. It's a degree 3, so we're looking for 3 solutions. Let's see. It's a plus sign, so looks like we have cubes. All right, cubes, so we're going to use SOP to factor this. Okay, so SOP. So same sign, opposite the plus. We're going to cube root these terms. So the cube root of x to the 3rd is x, and the cube root of 8 is 2. So 2 times 2 times 2 is 8. Okay, now we're going to square the x. That gives us x squared. We're going to square the 2. That gives us the 4. Then we're going to multiply the x and 2 together, and that's going to get us 2x. Alright, so this is factored all the way. Now we're going to solve it. So I can set x plus 2 equals 0, and I can set x squared minus 2x plus 4 equals 0. Now the x plus 2 equals 0, that's going to be the easy one, because we just subtract 2 over, and we get x equals negative 2. The other one, that's going to get us our 2 solutions that we're looking for, but you can't factor it. That will never factor. So you have to use the quadratic formula. So anytime you're solving and you're using the SOP, the trinomial part, you have to use the quadratic formula. All right, so let's go ahead and use the quadratic formula. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. All right, so we'll keep simplifying. 2 plus or minus square root of 4 minus 16 all over 2. 2 plus or minus square root of negative 12 all over 2. To pull the negative out, 2 plus or minus I root 12 over 2. I'm going to simplify radical 12. That's 4 times 3 and 2 times 2. So there's my pair. So I have 2 plus or minus 2I root 3 all over 2. And now I can divide all by 2 to get 1 plus or minus I root 3. Alright, so there's my three solutions. 1 plus or minus I root 3, and then the negative 2 that I found at the beginning. Alright, so that's probably the hardest one because that's the only one that you really have to use the quadratic formula on. As long as you know how to use it, it's not too bad, but that's what you have to use to solve the trinomial when you're using SOP. Okay, and that only occurs on the cubes. Okay, sum and difference of cubes. Alright, so if you have any questions, please ask.